Hi, I'm Helena Milevych, and today with
Dawid Lazaj, System Engineer at KP Labs.
we're holding the second podcast, and today we're speaking about the LeopardISS, which is a part of the IGNIS mission. So maybe a few words about what's the IGNIS mission. IGNIS mission is financed by the Ministry of the Development and Technology and coordinated by the Polish Space Agency in cooperation with the European Space Agency. And the idea that the mission is the part of the XM4 that will be launched in June. So today in particular, we're interested in one of the experiments that is already on the ISS, LeopardISS. So maybe let's start from the very beginning. David, tell us, what is Leopard DPU?
So Leopard DPU is a data processing unit. It is our product and a part of Smart Mission Ecosystem product line. It is primarily designed for nanosatellites, for rovers, so basically any space application.
Awesome. And what about the LeopardISS? What can you tell us about this experiment?
So LeopardISS experiment utilizes Leopard DPU as a core component of the core construction. It is a part of IGNIS mission, so it will be overseen by our second Polish astronaut, Sławosz Uznański-Wiśniewski, and it will be sent to the International Space Station and placed inside a facility called IceCubes facility, which is handled, overseen by a company called Space Application Services. The main objective of the LeopardISS mission is basically to allow other entities, companies, to test their algorithms, to test and validate their solutions on our platform, which allows for integrating machine learning algorithms and to extend the data processing capabilities.
And what I would like to add is that actually LeopardISS is one of the 13 experiments that is a part of the IGNIS mission. And what's more important, it was chosen out of the 66 proposals, 66 other experiments that the Polish Space Agency gained. So I think it's a great achievement, isn't it?
Yeah, I feel very distinguished, and that's an honor to be a part of IGNIS mission.
And how do you think why onboard data processing is becoming so important for the space industry?
So with the rapidly growing amount of data produced in space, grows the necessity to compress the data, to lower the size of the data. And if we were to continue the classical approach in which we gather all the data in orbit and send it all to the ground stations, we would soon reach a bottleneck. So in order to mitigate that problem, we introduce the artificial intelligence on board the satellites to reduce the amount of data that is produced.
So to bridge the gaps between the previous points, tell us more about the cooperation and our partnership with the Poznań University of Technology.
So the first application to be run on LeopardISS was prepared by a team from Poznań University of Technology. In the storage of Leopard, there is a dataset. It consists of images taken by a real rover moving through a difficult terrain. This terrain was supposed to imitate our moon. So the application prepared by a team from Poznań University of Technology allows for interpreting these images and recreating a real three-dimensional topography of this particular terrain surrounding the rover. And it also allows for recreating a real track, a real trail that this rover followed. So in other words, we will be able to see how the rover moved across this difficult terrain and what this terrain looked like.
This is very interesting application. So maybe let's talk about the other algorithms that could be run on board the Leopard Data Processing Unit.
So actually, this is not the first Leopard that we've launched. We also have our own satellite, Intuition 1, which has been in orbit for more than 500 days now. It is still fully operational, and it is equipped with a hyperspectral camera for Earth observation. This unit is equipped with special algorithm for image classification. So, Leopard can, in this picture, find where the clouds are. It can filter them out and verify if the image is cloudy or not. If this image is cloudy, it can be discarded because we do not have any interesting information in that picture. However, if the image is not cloudy, we can go a step further and use our other algorithm to classify the image. What do we achieve by that? So we can verify, for example, where the vegetations are, where is the bare soils, where are the roads. We can classify the image and downlink, so send to the ground center, only the mask of the image. For example, binary mask, which says, here are the roads in the picture and here are not. And this image is compressed and lightweight, so we do not spare a lot of the bandwidth.
And from what I remember, we also have other algorithms already tested in orbit. For example, algorithms for the telemetry detection, right? So this is also another example what we can run. So for example, satellites can do the self-check health monitoring to see if all these subcomponents working correctly, if there is any potential issue. So I would say it's one of the another examples, right?
Yeah, so the machine learning algorithms are supported by FPGA, which is an electronic system that is very vulnerable to the radiation. So we utilize a supervisor, which can interpret whether the code that exists in the FPGA works properly or not. That's one of the utilization of the machine learning in our components.
And what else I'm observing on the market is the trend for the in-orbit servicing and in-orbit operations, all the things that actually will face in the future. And this is a sweet spot where the onboard data processing and Leopard DPU could help, because we have the very tight margins to react to what's happening and how to rendezvous the other satellite, right?
Yeah, so on the market, there are algorithms that help in tracking and monitoring, which, as you said, is crucial because we need a very fast response time for these events. And if we reduce the weight of images to just these masks that say, here we have a fire and here we have not, it greatly reduces the responsiveness of the services.
Yeah, and that's a great example of crisis management, right? So we could actually use this type of data to save biomass, to save the environment, to help people actually in need. So which is also beneficial, not from the technological perspective, but also from us as humans.
Yeah, I think that utilizing artificial intelligence in space is just a necessary step to move forward and to keep the quality of services as high it is now and improve it. Because if we get too much data, we will get overwhelmed with this data. We have to reduce the data and react faster.
Yeah, and actually it's very interesting because according to some statistics, there are up to 80 or even 90% of the data sent back to the ground station is useless. So pretty much we pay for this data, we are using the bandwidth, but after all, we are keeping it on Earth, on servers, which is also, money and power and everything. And after all, we cannot use it. So it's also not friendly, let's say, way how we can utilize the data.
Yeah, that's why the cloud mask is a crucial first step in this selection, because at any moment, over 2/3 of Earth is covered by clouds. So we can imagine how big of a step it is if we can discard these cloudy images instead of unnecessarily sending them over to the ground.
Sure. So, taking into consideration safety and security requirements related to the human flights, from your perspective, what were the main challenges to adapt Leopard to the International Space Station?
So, since all the payloads are to be handled by astronauts, they must be extremely safe. In consequence, there is a set of requirements to be followed, safety, security related. And for example, there cannot be any holes large enough for the astronaut to put his finger in there, not to get wounded. Also, all the edges, the surfaces, there cannot be anything that would be considered sharp and that would tear your cotton glove when you move over the surface or over the edges. These are just some examples. Also, another example, if you have a fan mounted in the construction, it cannot be allowed over some margin. It would be considered unsafe for the astronauts. These safety-related requirements were probably one of the most demanding in process of designing and developing the product. Also, IceCube facility has set of requirements along with ISS, International Space Station, that are related to security, which means the hazards of the product related to the ISS itself. So, for example, we cannot upload anything we want to the ISS. All the software updates have to go through so-called security approval node. This is declaration given from ESA that this piece of software is safe for the ISS. It can be uploaded during the communication session. If we do not possess this security approval node, we cannot upload anything. So also the existing software that is already in the ISS must have been tested and hardened according to the instructions from the ISS. I would say that these safety and security requirements were the most demanding, and also there were a set of other requirements, for example, with the interface, because Leopard on its own doesn't have the proper interface to be plugged into the IceCube's facility. We must have developed an interface board. So all the requirements were tested in Belgium in the Space Application Services facility during the so-called interface test. It was performed like more than half a year ago, and fortunately it was successful and we've passed all the tests ideally. But it was really a danger in the project. It was a risk that if we have not passed this test so late in the project phase, we would not have been approved for the launch. So it is great that we've passed all the tests and the requirements.
Yeah, that's amazing. But also when you were mentioning these physical requirements, it's kind of reminded me the requirements toward the, I don't know, children toys, like the same with the holes or with the edges, that it should be smooth. So it's pretty interesting how the requirements that we use on Earth to a different category in different environment are actually the same that we have to take into consideration and follow when we have the ISS, a completely different environment, very scientific, but still they have a lot in common.
Yeah, I think it's important to mention also that all the payloads had the same set of requirements, but the intensity of the testing was different for a different payload, because in our case, LeopardISS will be only plugged into the ISS by astronauts, but there will be no further interaction between astronauts and the hardware. And there are some experiments that are that will interface with the human being for a longer period, so they must have tested their payloads more intensively than us.
Yeah, and I believe the same applies to the bio experiment.
Yeah.
some plants or other forms of, let's say, bacteria, etc. So definitely this is something that, should be tested and verified before sending to this extreme environment.
Yeah, not to endanger the life of the astronauts.
Yes, obviously. As we already tackled the testing campaign for the LeopardISS, can you tell in a bit more details what other tasks we had to do to prepare and simulate the environments of the LEO to make sure that Leopard could fly to the International Space Station?
Yeah, so Leopard is flight-proven product. It has its flight heritage, as I mentioned earlier, in the Intuition 1 satellite. It is vibration tested, and it can withstand most of the modern launchers and their vibration levels. Also, since we send the payload into the space, we have to prepare our products for the radiation and thermal and pressure environment that is present in there. And in KP Labs laboratories, we have a so-called TVAC. It is thermal vacuum chamber, and it basically imitates the vacuum level and the temperature that is present in space. So in this facility, we test our components and test whether they are ready for the flight. Also, we have a climatic chamber, which we used for the so-called thermal cycles. It's basically to check how the construction reacts to the changing temperature and that is present in the ambience. Some of the tests we have not been able to perform in the laboratories because they demand aperture that is not present in here. One example is the radiation campaign, for which we've used facilities that are present in Poland and also abroad.
Mm-hmm.
So Leopard must have traveled abroad also for some of the tests.
Yeah, and maybe if you can somehow highlight what's the difference between the regular tests if you want to launch Leopard as a part of the satellite and versus the ISS, if there are any difference in these testing campaigns.
Yes, so when we send something on our own to our launch in orbit, we do not necessarily have any strict regulations that are on us. We have to basically be sure on our own that the construction will survive.
Mm-hmm.
So when speaking about the International Space Station, we have this set of regulations that says you have to perform this, and be under this limit to even be allowed to send your payload to the United States of America to be launched in the ISS.
So pretty much we have two levels of, let's say, testing campaigns. The first one is always applied to the launcher and we have to follow these requirements. But in this case, also we have to follow the requirements of the International Space Station and prove that the payload is safe and is, under all the restrictions and all the limitations and is no harm to the human who are in there.
Yeah, also during the regular missions, if you pay for a space in launcher, you paid. It's okay. The launcher is satisfied. But if you are qualified, like us, for a mission to the ISS, we take a space that could be filled with other experiments. So if we are qualified to be selected to perform this task, we must follow the strict regulations, because otherwise we've wasted a space for another experiment. The 13 experiments that have been selected for the IGNIS mission were selected among 66 candidates. Mm-hmm. So it would be painful for the others if we wasted their slot, right?
So if you have any questions, please leave the comments below and we're happy to tackle them in the next episodes. And of course, the biggest happening is the actual launch of the XM4 with our astronauts. So you're very welcome to follow this launch, to watch it online as it will be transmitted. So for sure, we as a Cape Labs team will be gathered in an office to follow this event. So I also hope you will enjoy it with us. Thank you for watching us.
Thank you.